So linked lists, within that, as I briefed, that linked list can be classified into three types: singly linked list, doubly linked list, circular linked list. Singly linked list, it consists of one data, okay, and one pointer. Okay, the pointer field consisting of an address of next node. Okay, data means information. Doubly linked list, it has one data field and two pointers. It consists of information field, that is called data, and two pointer fields. The first pointer field, it it indicates to previous node. Suppose if this is the node, so it has two pointers, and one pointer indicates the previous node and one pointer indicates the next node. That's why it is called doubly linked. It has two pointer fields. Okay, one field, information field, consists of the data, and that one pointer field contains address of the previous node, and second one consists of the address of the next node. Okay, so we can travel backward and forward. Okay, in doubly linked list we can travel through the list backward and two directions. Okay, in singly linked list only one direction we can travel. Circular linked list, it is similar to the singly linked list, but difference is that the last node, suppose is last node in singly linked list, the last node will not have any address, null. The pointer, there is no any address here. But in circular linked list, last node consists of the address of the first node. So there is a loop between last node to first node. So the loop is circle. Okay, last node will have the address of the first node. So last node contains the address of the first node. So that's why it's called circular linked list. What are the applications of the linked list? That is very important. We need to understand that. So linked list will be implemented with the help of. So the linked list help us to implement stacks, queues. So by the help of linked list, we can implement stacks, queues, binary trees, and graphs of predefined size. Stacks, queues, these will come under linear data structures. Trees and graphs, they will come under non-linear data structure. So with the help of linked list, we can implement stacks, queues, binary trees. Okay, binary tree is part of trees, and graphs of predefined size. So we can also implement operating system functions for dynamic memory management. I told you that static memory management and dynamic memory management. Static memory management, static memory is fixed, so you can't change the memory. Dynamic memory management, the memory can be changed at the time of runtime. Okay, so operating systems function for dynamic memory management that can be implemented by linked lists. So for mathematical operations of polynomial implementation, polynomials, if you want to implement polynomial implementation in mathematics, okay, we can use the linked lists. So circular linked list, they can be used in operating systems, implementation operating systems, applications of operating systems, which will be including round robin execution of tasks. So everything we will discuss whenever we will do the practicals, write the code. That moment you can simply understand all the things. So circular linked list is also helpful in slideshow. Okay, where user requires to go back to the first slide, after that last slide is presented. Okay, slideshow, where he goes back to the first slide, then after the last slide is presented. So doubly linked list is utilized to implement forward and backward buttons. So doubly linked list we can, it has two pointer fields. That's why one pointer points to the previous node and second pointer points to the last node. So that's why we can travel through front and back to two directions. So by doubly linked list implemented forward and backward. Okay, a browser, suppose the browser in browser has two buttons like forward button and backward buttons. So to move forward and backward in browser, okay, that moment doubly linked list will be used to implement forward and backward buttons in the browser. So somewhat applications. So until unless you will not do any practicals, all these applications, whenever you implement them in ground level execution, that moment you can understand all this. Okay, so next is word stack. So up to in linear data structures we try to understand first that is what array, and then different types of arrays, one dimensional, two dimensional, multi-dimensional arrays. We need to do all of them in practically, we need to implement them. Next is what linked list. Okay, so linked list. By linked list I have told how that linked list I defined. Okay, there's two fields, data and that is what pointer field. Pointer field will have the address and it points to the next node. Okay, but last node that will not have the address of next node. So that's why there is no any address, so that is called null. So already I have briefed. Now come to the stacks. Stacks is what? Stacks. Before the stacks, I want to within this I want to brief some words which are related with arrays. So within the arrays we need to study so many, within the array so many bubble sort arrays there, selection sort array, insertion sort, kick sort, counting sort, radix sort, merge sort, linear search, binary search. These are all the part of arrays. We need to study one by one: bubble sort, selection sort, insertion sort, kick sort, counting sort, radix sort, merge. These are what in linked list. Okay, we need to study, we will study linked list. Okay, no issue. And linked list, as I told you, that simply linked list, doubly linked list, circular linked list we need to study. And array, as I told you, that array, it will be used to store same type of data element. Okay, array will be used to store that elements belonging to the same data type. If array is declared as integer, so we can store only integer type. If array is declared as float, we can store only float type of data elements. If array is declared as character array, so we can store only character type of data, only same type of elements. I told you that once same type of elements are being stored, they are called that is homogeneous data structure. Homogeneous means same type of data elements are being stored. Okay, if different type of data elements are stored in a data structure, suppose like in Python list can be stored with the different elements. You can store integers, floats, and complex numbers, boolean, string. So list can be permit us to store different type of data elements. Okay, so as we have discussed that data structures of that is what initially we are non-primitive data structures, they will be used to store multiple values. Okay, next arrays acts as auxiliary storage for other data structures. Array also helps store data elements of a binary tree of the fixed count. So whenever we want to store data elements of a binary tree, a fixed count. That moment whenever we will try we will